We lined up with an addiction counselor then. Okay, so today we're doing the average value of a function, and then we're doing displacement and distance traveled and so on by particles along a function. So, first of all, average value of a function. Find the average value of a function. To find the average value of f of x, you take that goes from a to b. You take 1 over b minus a times the integral from a to b of f of x dx. And you go, well, that's really complicated. Really, it's not too bad. Okay? So for this function, it'd be 1 over, this is a and this is b. So it'd be 5 minus 3, the integral from 3 to 5 of 6x squared plus 8 dx. Now there's going to be no c because you have numbers there, which makes it a definite integral. Okay? So, whoops. So, this is 1/2. If we integrate this, 6x squared becomes what? 2x cubed plus 8x from 5 to 3. So it's 1/2 of 2 times 125 plus 8 times 5 minus 2 times 27 minus 8 times 3. So it's 1/2 of, this is 250 plus 40 is 290 minus 54 minus 24 is 30. So it's half of 260, which is 130. Okay. What? No, because you'll do it enough, you'll get it down. All right. So the average value of this function. So you go 1 over 9 minus a negative 5 for the integral of x to the 1/3 power from negative 5 to 9. Well, what's the integral of, well, first, what's 9 minus negative 5? 14. And then x to the 1/3 power makes it x to the 4/3 power with a what in front? 3/4 from 9 to negative 5. Well, if you multiply these two, you get 3/56, right? And then it's x, or it's, well, 9 to the 4/3 minus negative 5 to the 4/3. So 356, 9 to the 4/3 minus negative 5 to the 4/3. Well, if you take it to the negative 5 to the 4th power and then cube root it, you're going to get a positive, so that negative just goes out of there. So it would be this one. You good with that? Okay, this one's a little tricky. Okay, so average value is 1 over what minus what? 7 minus negative 2 of the integral of the cosine of x. What's the integral of cosine of x dx? Positive sine of x from negative 2 to 7 From 7 to -2. All right, so it's 1/9 the sine of 7 minus the sine of -2. Okay, now you got to remember back to trig again. Some poor people didn't take trig, and that really stinks. But this is an odd function. The sine of an odd function, if it's negative, brings the negative out front. So it's 1/9 the sine of 7 plus the sine of 2. Because the negative comes out front if it's an odd function. Cosine is an even function, so that negative sign just disappears and it still stays negative out front. Cosine's an even function, so it doesn't change the sign in front. Sine's an odd function, so it does change the sign out front. The negative comes out. Cosine, the negative doesn't come out. Okay, so this would be the answer, which would be choice A. Okay, average value functions. We all right with those? Okay. Besides average value functions, we're dealing with particles moving along a line. Okay. The three things we're doing here is position is from start to end. What totally happens from start to end? Okay. Distance traveled is the absolute value of the integral, or the integral of the absolute value, however you want to say it. And then the displacement is just the integral. Displacement is the where you start from, where you end from, just from there. Position from 0 is you might start at a different point, so you have to add that in. And distance traveled is just the absolute value of, because it might go back and forth. Okay? So this one, a particle moves along a straight line at v sub t meters per second, where t is the time in seconds. At t equals 2, the particle's distance from the starting point was 10 meters in the positive direction. What's a particle's position at t equals 9? So it's a position. So from start to end, what happens? Well, it starts at 10 meters. That's where it starts at. So you have to add on that to the integral. These, distance traveled and displacement, you do not add anything onto the integrals. But when it's a position, you add it onto the integral. Now, what's the integral of? Well, the integral starts at 2 seconds and ends at 9 seconds. So it's from 2 to 9 of the velocity function. Okay? So, which would be this one. Okay? So that's position. You add on to the integral the starting plus the integral. Distance traveled is just the absolute value of the integral. Displacement is just the integral. Okay? A particle moves along a line, v sub t, where t is the time. At 2 seconds, the particle's distance from the starting point is 5. What is the total distance? It's not position. It's not displacement. It's total distance. So the total distance is the absolute value of the integral, or the integral of the absolute value. And then when you have displacement, it's just the integral from the starting to the ending point. So it's just the integral. This is distance. This is displacement. And this is position. So you need to keep those straight. What is the position versus 0, 0? Well, it was already at 2, and then from 1 to 6, it went certain displacement. Here's the displacement, and here's the total distance traveled. Okay. So now, without any help, a particle with this position moves in a straight line. How far does a particle move from here to here? How far it moves is its distance. So it's the integral from 2 to 3 of t squared plus 3, the absolute value of it, dt. Okay? So this is the absolute value of 1/3 t cubed plus 3t from 2 to 3. So if you stick in the 3, 1/3 of 27 plus 9 minus 1/3 of 8 plus 6. Well, 1/3 of 27 is 9. 9 plus 9 is 18 minus 8/3 plus 6. 6 is the same as 18/3. So 8/3 plus 18/3 is 26/3. Well, if you put this over 3, 18 times 3 is 54. So this is 54/3 minus 26/3, which gives me 28/3. And that's how far the particle moves. Here it's looking for position. So what do we start with? We start with a 2 because that's a position at 4 seconds. And then we go the integral from 4 till t of 1 over the square root of t dt. And I think that's where it would end. Okay. So that's the basics of what we're doing today. Yes, you're going to be assigned a billion things today. Okay. But you have, well over an hour to work on this, plus watch the videos, plus you got some time between now and Thursday too, and so on. So, yes, you're going to get a lot, but you're not going to be asked to do a whole lot more the rest of the class period. So, besides just doing your work and watching your videos. So let me get this stuff out to you. Boom, stop the video.